Number line is what you all think it is. It's a number line, but we're going to use it now to represent multiple solutions. So rather than just being able to say the answer is 4, I can show on a number line that the answer is anything less than 4, anything greater than 4. Because the number line can represent an infinite amount of numbers because the arrows are continuing on forever and ever and ever. Those arrows, that's what the arrow means. You should, on your number line, plot at least 3 numbers. Because then it's easy to see a number that's on target, a number that's below, and a number that's above. You could have an open circle, which means the solution is not included. And you could have a closed circle, which I'll show you what that means. We'll give an example of both. Circle, which means your solution is included. I should have provided more space to write, but I didn't, so I'm sorry. So, your number line needs at least 3 numbers, and it's used to represent multiple solutions. So, for example, if I said x is greater than 4, that means x could be anything as long as it's greater than 4. I'm going to include -4 on my number line, 0 on my number line, and 4 on my number line. It's a good practice to include 0 on your number line, just because 0 is a good, the word has escaped me, but like you all know where 0 is. It's easy for you to picture a 0 because it's 0. Okay, 0 is, or x is greater than 4. So I know that it's going to be any of the numbers that are bigger than 4. It's going to go this way. My arrow is going to say anything bigger than 4. Is 4 greater than 4? No. So will x is greater than 4 include 4? No. So it's going to be what's called an open circle. It doesn't mean the circle's open. It means it's not full. So that. Okay? So if I saw that number line, I would know, okay, my solution does not include 4, but it's bigger than 4. It comes up to the very, very edge of 4. It could be 4.0000000000001. Okay, so it's really close to 4, but it's not 4. X is less than 4. I would still include a 0, a -4, and a 4. There's no right or wrong numbers to include on your number line, but it's easy to include the negative, the 0, and the positive. Okay, if x is less than 4, it's going to go to the left. Is 4 less than 4? No, so will it include 4? So it will be an open circle, what we call an open circle. Okay, x is greater than or equal to 4. Same labels. Okay, x is greater than, that means it's going to go this way. Or equal to 4. Is 4 greater than or equal to 4? Because it says or equal to. So that's when we use what's called a closed circle. So it's filled in. All right, x is less than or equal to 4. So -4, 0, +4. So it's less than, so it's going to be this direction. Or equal to means it's what type of circle? Closed. Okay. So I usually try to make my arrows thick so they, especially when you draw your arrow pretty close to the number line, so it's distinguishable. Okay. Next is the inequality. So an inequality just uses the symbols greater than, less than, greater than or equal to, or less than or equal to. There's also not equal to, but we're not going to do ones like that right now. So we want to write from words to an inequality. So x is greater than 4. That one's pretty easy. Which symbol's going to go there? What? Greater than. So if I just read this, I would read x is greater than 4, which is what I'm supposed to have written. X is less than 4. X is greater than or equal to 4. And x is less than or equal to 4. Remember, we are going to do the bottom two sections later, so you don't need to worry about those two. All right, and last is interval notation. We are going to introduce interval notation, but and you're going to use it a little bit, but you're going to learn more about it later in high school.
Pardon the interruption, but I need to get Julia Breeden to reception, please.
Okay.
Thank you.
Okay, so interval notation is a way to list the endpoint from left to right. So there's a couple different notations. There's a regular, like parentheses. Those are what we use when we have open circles. Then there's our like robot brackets. That's the word I like to say. Those are what we use with closed circles. And then a positive infinity and a negative infinity is what we use with our arrows. So I'm going to let you write that down, and then I'm going to show you what that means. It sounds a lot more complicated than it really is. It's basically another way to write x is greater than 4. So, if I look at my number line, I'm starting at 4, and I'm going on forever and ever and ever. And the numerical symbol for forever and ever and ever is infinity, and I'm going in the positive direction. Is my circle open or closed? Open, so I'm going to use the regular parentheses. And since there's no stopping point on infinity, I use the regular parentheses. These regular parentheses, basically, I think of them as like softer, like they don't include it or they go on for ever and ever. They're not as like harsh as a bracket. Okay? All right. On our next one, where does my arrow start on the left? If I ask for a numerical representation, where does this arrow start? What? Negative infinity, because it goes on forever. If I had to continue this arrow, I'd never stop. So it's at negative infinity because it's on the left. And where does it end? 4. But does it include 4? No. So that's why. So this would mean it stops at 4, but it doesn't include 4. And we're still going to use our soft parentheses because it goes toward infinity, but there's no like real way I can visualize where it ends. Or begins, I guess, in this case. Okay. The third one is a closed circle at 4. So it starts at 4. And where does it end? Positive infinity. It includes 4, and it's a closed circle. So this is when we use this. Because this means it includes 4. If I just saw this, I'd say it includes 4, goes on forever and ever. The arrows, if it's infinity, it's always going to be a regular parentheses. And then our last one, where does it start? Negative infinity. Always use this type of parentheses. And where does it end? 4. And does it include 4? Okay. We will keep practicing interval notation. Okay. On the back, there are some problems where all you're doing is writing interval notation, the inequality, and you are graphing it. Number 1 is a challenge problem, but I think you'll be able to do it. It's just we haven't taught you. I actually don't know why it's a challenge problem, but oh, the interval part is the challenge part. I see. Okay, I forgot why I did that. All the intervals I want you to try, but they are the challenge portion. You should be able to graph and write the inequality for all of them. When I say write the inequality, I just want an X on the left. Okay? So you need to solve for X. Actually, we're going to do some of them together. Sorry. Let's do a couple together. All right, let's do number 1 together. How would I get the X by itself? Subtract 2. So X is going to be greater than negative 14. I don't know why I put this on the back of it. Oh, I know why. Because this is what we're going to do on Wednesday. Okay, so you don't need to solve these. What I do want you to do, sorry, I got ahead of myself. You don't need to solve them.